and the magnetic field must always be at right angles for induction to take place. Another thing that affects the rate of induction is the number of turns on the armature coil. The more turns, the stronger or the more electricity will be produced. Also, the type of material that is used the type of material that is used to make the armature loop that affects it as well. Then, of course, the speed at which the conductor is moving in the magnetic field, that also affects the amount of current that can be induced inside this. All right, so by way of note, now these, okay, the difference between AC and DC generators. These machines differ in the way that they are connected to the external
Right.
circuit. So AC generators will carry slip rings, while DC generators have a device called a commutator. All right, now I need to find the diagram. 1 second. Nope. All right, I have DC generators on a separate slide. I really didn't want to confuse you by doing that. All right, so memorize this and note that the key and important part of the AC generator for you to know, you have to know what is the function of the brushes. You also have to know the function of the slip ring, and you also have to know the function of the armature or the wire. Another key thing to note about the slip rings is this. The reason this generator is called an AC generator is because it's called alternating current. Alternating current moves in a waveform, a sinusoidal wave. Let me show you that with a whiteboard. I'll show you that with this whiteboard. All right, so what's going on here? All right, so in a normal graph, that's supposed to be a straight line. In a normal graph, you have two axes. What are the two axes in a graph?
X and Y.
X and Y. So now, when if this is the starting point, an AC alternating current will move from 0 to peak positive, down to 0, then from 0 to peak negative, and back to 0. Right? So now this here, this point would be 0. This point up here will be positive peak.
So the peak don't have like a specific number.
Yes, it depends on the value of the voltage. And can someone say What's
Yes.
the, sorry,
Levi?
somebody talking? Okay, somebody else on. All right, yeah. Can somebody say what is the peak voltage that we have in the Bahamas for a single phase house? What's the peak voltage?
What you mean? The most voltage we could use in the Bahamas?
The most voltage that you would get in your house right now.
On my house?
Mommy, my fair. Mommy.
What? 1,008.
No, you try. What you have a whole Southwest Plaza you live in it. What's the
500.
highest voltage in anybody's house that's supplied by a three wire
450.
system? Mm-mm.
500. 600.
No, you're too high.
Teacher, I'm too far along, mommy.
250.
Right, 250.
Oh,
So if you are using let me see. If you're using a circuit that requires a double pole breaker, then your peak will be 250 volts. Now this
Oh,
200,
you mean for something separate? I thought you meant for like the whole house.
yeah, the whole house is
But the whole house
250
will work.
volts, right? Now,
Yeah?
yes. So if you have central AC or if you're
market.
all right, if you have central AC or if you have anything that uses high voltage, the highest voltage you could get in your house right now is 250 volts. Now, what I'm saying in an AC generator, when it starts to operate and voltage starts to be generated inside that armature coil, this voltage now moves from 0 and will top off at 250 volts. Then now, as the armature moves again, it's gonna go down to 0 and move in another direction, but it will also top off at 250 volts. This entire movement from 0 to the end here is called an entire cycle. And these cycles take place every second. Cycles are measured in the unit called hertz. And in the Bahamas, we use 60 hertz. Our cycle is 60 hertz, which means 60.
Wait, Spence.
Yeah, I hear you now.
All right then.
60 cycles per second. This means that every second you have 60 cycles of electric energy flowing through your conductors in your AC system. So that is why when you plug a tester, and when we get a chance to go back, we use the tester and test the voltage. When you test the voltage in a socket, it will start at, let's say it's a 120 volt socket. It will start at say at 110, and then it will eventually go up to 115, 120, and then stabilize. Which simply means that if you're not getting the peak voltage in all the sockets in your house, it simply means there's something that is pulling the voltage in the wrong direction, or it could simply mean that you have too many things connected to one circuit. Therefore, the entire quality or quantity of voltage cannot be distributed evenly. So again, an AC generator is called an alternator. It's called an alternator. And we see why it's called an alternator. The purpose of the slip rings, SLIP rings, the slip rings connect to the armature coil, but they also reverse the connection every time the voltage changes direction. Let's get that again. Slip rings reverse the direction every time the conductor, slip rings reverse the direction every time the conductor, I said it right the first time. Slip rings reverse the connection every time the conductor changes direction, so that the voltage will remain as valid, but the direction is indicated or shown by the peak. Now, the distance between the peak and the base, this particular distance right here, it is called the amplitude. Amplitude of a wave is the height of the wave. Okay? And we said also from this point here, from this point here, let me draw it down. From here to here is known as a cycle. All right? The entire distance is known as a cycle. And we said that in the Bahamas, we use 60 cycles per second, or 60 hertz. Hertz is the unit of cycles. We also said that an AC generator is called an alternator. All right. The important part is slip ring. The another important part are the brushes. Anybody remember what I said about the brushes? Anybody remember what I said about the brushes? No?